All right. Is it okay if I ask for people to say hello? Maybe let's
Yes.
spend 4 minutes and just um, if you've had a class with Design Engine, speak up, say hello. If you
I'll
haven't
speak
had one,
now.
say hello. Introduce yourself. How many people do we have on, Deb?
I can speak up. This is Tim. I
Speakers
work for
on.
KI for about close to 14 years now. I've been to a few Badger land user groups. I've been to Bart's classes in a past job for like motorcycle seating and those type of equipment. Looking forward to sheet metal to see what kind of tips and tricks you have.
Did you work at Milsco, Tim?
I worked at Dalco for a while, so we worked with
Ah,
Harley and the metrics as well.
good. Good
I
to hear
worked
your
at
voice.
I worked at Millsco Bard,
Oh, okay. Yeah,
so
I
I've
think I
done a
did a
few.
2-day class at Milsco. It was
Yep.
a lot to throw in 2 days, you know?
Yeah, I was down in Chicago for a couple of classes with you for a week at a time.
Good. Anybody else want to say a quick hello? While we get a couple introductions and hellos, Deb, can you check to see if anybody signed up at the last minute?
Not easily. I see that we've got 33 people. It looks like 33. Do you guys agree that I've got this 11-inch laptop? I can't see that good.
Okay, so I'm logging into the Design Engine training material, and I just want to say that Design Engine's been very geared at product development over the years. We've got a team of people that's all they do is product design, and I'm excited to push us from working with industrial designers and engineers who want to work with industrial designers to actually manufacturing. And a lot of the classes, almost every class we do is with respect to a production part, and it's got draft on it. Maybe we're taking a forged, let's see, a welded kickstand for Harley and converting it to a forging. That's part of our forgings class, for example. And so lots of really cool, exciting projects. So what I've been doing with the sheet metal, which I think is really cool, is I teach probably 2 or 3 sheet metal classes in SolidWorks per year, and I'm just combining the whole class, whether it's SolidWorks or Creo. It doesn't matter to me. I'm capable of doing the example in either software, but I've got the part in Creo to download to play with it. So I just want to talk through a little bit of what I've been teaching sheet metal classes for 30 years, and I learned sheet metal at the racetrack. You crash a motocross bike or a sport bike, and the titanium exhaust bends, and you've got to fabricate a new mount because you don't bend titanium back, it'll tear. So you have to create a new sheet metal bracket right there at the track. So it's vice crescent wrench, and which is funny because we don't take into account any stretch YK factor that occurs. Um, so I thought what I would do is just kind of do a real quick introduction of the class, and then you guys speak up and tell me what you want to see, and we'll just wing it like that. So I did a 4-day sheet metal class to a military group recently, and most everybody had some experience in sheet metal, but in 4 days we can push some really exciting examples using top-down design to push things around. I'm just going to scroll all the way to the bottom of this class and point to that. So I just recently did 4 weeks of training at Newell Rubbermaid, and this happened to be sitting on the desk. It's a sheet metal part that's bent. Built that all with top-down design, fetch a surface out of it, and then how do you put the holes in? Right? You put the holes in the flat, or maybe it comes as a sheet, perforated sheet, and it's bent up in that way. But in Creo, you've got the bent up shape. What do you do to build all that? So I just put that at the end recently, and in Creo, in design engine speak, anything with 1100 on it means it's done in Creo 11. Okay, so I'm just going to scroll all the way back up to the top. And this example are some skate trucks that aren't made with sheet metal. And your challenge is to use the same points that we created the trucks with, top-down design oriented geometry, and then put this spring part in, same points but a spring. So interesting project. This one is an IGES file. This is something that you get download from McMaster-Carr and you can buy quantities of. How do I make a bracket looking at a step file? Right? Of course, you could we're going to figure all that stuff out. But the classes are all wide variety of examples, and as you can imagine, exciting. Right? Design engine classes you don't fall asleep in. So with that kind of quick introduction said, I don't know, I thought we'd start out kind of simple and build something like this. The examples can range. I'll just let you guys start throwing stuff out there. Here's a latch for your door in an F-150. What points are significant and how do we organize this? This sandcast or die-cast steel part, right? What's significant about this bracket is this distance, because that part probably already exists. So we're trying to nail all those geometries. Here's the part that you can buy. Maybe you got a step file and you've got to make a bracket mount to it. There, that the example, right? So if nobody's going to kind of throw out some thoughts, I'm just going to quickly build this shape here and think about how, we'll start out kind of simple. What do I do to build that? Design engine's very geared at it's not how fast you model something, but how fast you change it 20 times that makes you kind of an expert, and yeah, we can model it quickly, but if you can't change it, right, you're not the expert, right? So I like to say an expert would never tell somebody that they're an expert. They would wait for somebody to tell them that they're experts, right? So whatever the diameter is of this thing, is anybody in Creo 11 yet?
Yeah.
Nope.
Design engine, we just use whatever software the customer tells us to, so it's not a big deal. Somebody's going to say something. I interrupted.
Hey Bart. Yeah. I had a quick question kind of related to what you're discussing. Do you have any recommendations for how do you start just making a sheet metal part? Do you just want to put your pen to the pad, or do you want to think about it ahead of time?
That's what I did. I started going to the pad and I'm sketching stuff in Creo. So if you're working for the military, I don't mean to be insulting, but the military documents are all built in the 1990s, back when people were doing bad practice in stuff, right? So I just went and started into Creo. But if I wanted to, I could extrude this part and convert it to sheet metal. So, if you're a contract agency working in military, this is not how they want you to build it, right? So I can come over here and literally convert this thing to sheet metal. I don't know which. I tend to err on clicking on the side that was the sketch is sketched upon, right? And now I can build a bend across here to try to bend the thing down, right? So let's do that. I'm just going to get my head wrapped around the shape. It's a circle. It kind of comes to a point. I'll redefine that sketch to kind of organize that shape. So me and design engine itself, we're kind of, I would say, new school. We don't think that, I don't know about you guys, but I'm kind of a rule breaker, not a rule maker, So I don't, best practice is kind of a rule, I suppose. Hey, did you know this? I don't need a center line to force symmetry anymore. Did anybody tell me when that was new? I think that was new in Creo 7 or 6. All right, so whatever I modify this to, or you could drag it with your mouse, right? That's pretty cool. All right, so that looks like the flattened state. I keep losing where my picture is. Yeah. All right, now I got to create the cut on the inside. Well, people that count features would update this and make it more complicated. I'm not a counter, so I don't think it really matters. I'm just going to encourage the team to use all the cool new tools in Creo. You see how I'm highlighting the datum plane? Don't ignore this pop-up window. I've been trying to encourage PTC to let me customize, right? You can right hold down and customize this, but I want it to be like a marker menu and alias. I haven't actually shown how that works to PTC, but I think that would be the next step, in terms of having, AI is the next step. But I want to customize this geometry here. So I'm just going to quickly build. See, I'm fetching the horizontal and the vertical. So I'm taking advantage of all the middle click, left click, delete. I'm taking advantage of all the assumptions that I can leverage. I shouldn't mention SolidWorks, but SolidWorks doesn't have all that stuff. They started to go down that road. They just didn't finish it. Now I can use my coincident constraint to align this end to that end, right? So we'll just left click on that and turn it to a diameter, right? And forgive me, I'm not thinking about the size, whatever. So a lot of folks, I'll tell you, if you give me people that have 20 to 30,000 hours on Creo, with Creo update training, I can get them 30% faster. Most people don't know you can right click on these dots. That was new in Wildfire 5. Nobody's doing it. So my goal is to be new school. And also, most MEs don't know you can drag stuff around in Creo. And if they did, they would lock the dimensions in sketcher mode, so you can't do it. All right, so there's my basic shape. Now I'm going to, this was my feature to convert to sheet metal. I don't know whose voice that was, but the question was, do I go file new and start with a sheet metal part? If you work for the US military, there's a 70-page document that says you have to start with a sheet metal part, right? You can't start with a solid part and convert it to sheet metal. No big deal. So now I'm in sheet metal. I'm in the tab for sheet metal, and I'm just going to reach for the bend utility. I click on the part. Now, I don't know what year this was new, but PTC wanted to be able to show off the utility, I suppose. This is what you see is what you get, dragger utility. I personally don't use it. It's cute and everything and great for sales, right? And you can drag all this stuff. I just want it to be straight across, right? So what we've done for 30 years in this utility, I think I started playing with sheet metal in 1992, is you take the bend line back to the sketch. See, I lost that whole thing that I just did, so it's not even helpful. It's just create something that's absolutely straight across. Look, I got the automatic vertical. So I think that's a basic bend, Now, if I wanted to put some holes in here, you got to bend the thing back, add your holes in the flattened state, and then, I hit bend back, unbend, and then you add your holes, and then you hit bend back to get it back to what you had. I'm on the technical committee for sheet metal, but I haven't ever joined the meeting and talked about it. But if you do a bend and a bend back and add holes, I would want that in the model tree indented just a little bit. designers can see that if they want to add something in the flattened state, they just go to insert mode and add it. Questions, thoughts, comments? Also, I think in the Learn to Design course, if you give me some young people to teach in the course, what I do is I teach them how to use the drawing intelligently. Now, I've done this for a lot of SolidWorks users from Stanford and California, whatever, that everybody thinks they know SolidWorks, right? Or Creo for that matter. So what I did is I left click on all the features in the model tree and show those in the model. Do that again. I clicking too quickly. You know, in any features that get displayed in, you know, over here are parametric, and I can modify them. There's my diameter. Oh, that's supposed to be 16 inches, right? So I could just double click on it and type in 16 and Control G. And when I do that in a class, everybody's like, okay, I'm sold on Creo, you know, because they're SolidWorks. They did one semester in college, you know. So what I'm trying to say is SolidWorks does that too, right? So this number is where the bend starts. Here, let's type in 12 and see what happens. If the bend fails, okay, no, it was the overall length. The bend is going to be in another model, right? Or in another view. So I would hope that for most people that's not new, right? I can double click on this diameter and you know, change that number and hit Control G in the keyboard and get that to update. Now it's a little bit too small, so I can change this one, make that a little bigger. Each change, I'm hoping and praying it doesn't fail and explode and freak me out, you know. But so using the drawing as a tool can be extraordinarily helpful. So that first feature, I'm just going to make this one a little bit bigger, you know. And oh, now my bend is failing. Can you guess what would be the problem with the bend? So we just edit definition on it and kind of wade through it and see the bend is a little bit too far up, right? So it needed to be, you know, for all the changes that I'm making on my model. All right. So let's think about how we want to control how the bend is communicated to, you know, I'm going to do it this way. Why is that? Oh, get rid of that dimension. So it was controlling where the bend was with a horizontal dimension. I wanted this one, right? So let's check out of that. The bend's not failing anymore. So just being comfortable in fail mode. Here's a really cool little trick. I'm going to left click on this edge and this edge, holding the control key down for the second one. Don't ignore this pop-up window. There's the round. Don't move all the way across Africa and grab full round. Explore what's underneath your right mouse button. You can fetch the full round out of there. I'm not a counter, so I would do that as a separate round on the other side. But if you're open-minded and want to play with these things, we're going to hit new set and do the same thing on the new set. Right, hold down. Whoops. I clicked off the feature. Right, hold down, full around. So I could have done that before I put the bend on or after, and there's the unbend. All right. Thoughts, comments? Like, you want to go to something more advanced? I got this.
Hey Bart, can you hear me?
Yes, sir.
Would you mind doing that kind of stainless steel looking thing that's below the generator picture? I believe. Go up. Keep going. A little more. Right there.
The louvers.
Uh-huh. Or do you think that's a
Actually, that's where I was just going with it. This little flag that's for your mailbox, right? It's a form
Yep.
feature. It's got, I don't know if you can, I'll stop sharing so you can see the bigger screen. It's got an indentation. It's just stamped. A lot of people think stamping something costs more. It's actually can be cheaper. The tool to stamp this probably only costs $200, $300, $400. And now you can pop them out faster. And the stamp can actually cut the outside of it. So yeah, let's do one real quick. And then I'll do a louver second. Okay, so there's value of starting with the solid part. The idea is if you start with a sheet metal part, you can't save it out and create a tool for it. I'm just going to do a couple of these real quick. I'm going to build a little part that goes in the back of your computer that fills the slot for where your video card goes. So that little sheet metal part looks a little bit like that. So I'm just going to extrude. Automatically, it turns to a surface. I'll do solid and thicken. So I've met a lot of people over the years that sometimes they have a bad attitude. They're like, I don't need to learn sheet metal. I can model anything in Creo without the sheet metal module. That's probably true, but the sheet metal module is so convenient. You wouldn't do that if you took a minute to learn the sheet metal module. So I don't think doing a thicken is a great, sort of way to build your sheet metal part, All right, so I did that. Now I'm going to rename this and call it clip or whatever. And then I'm going to save the file. Then I'm going to save as a new name. Now, the reason I'm doing this is because I'm trying to build a form feature, a tool that I can have machined. And, so I'm going to call this the same part name _ tool. If I did it as a sheet metal part, I wouldn't necessarily be able to convert the other one as effectively. All right. So, right. So I'm saying it's a good practice to start with a sheet metal part, but in this case, I didn't do it. So here I'm going to convert this one to a sheet metal part. If it doesn't convert to a sheet metal part, your problem probably is that wherever you got it from, there's a 16 thousandths of an inch wall, and one of the other walls is 17 thousandths of an inch, or 18 gauge or something. It's a little off, so that won't convert, right? So your logic would be simple to how to fix it if you knew what the problem might be. All right, so I'm going to do a search for CL star for clip and find that tool on my drive. And then I'm going to delete the extrude on this. The sketch can remain the same. I like having the sketch there because this is how I don't have to get my orientation just right on my tool. All right, so I'm going to delete, this stuff, and turn it to a big piece of steel. My thought is a typewriter is basically a form punch, and if you feel the paper that the punch made, you can feel the bump for the letter that hit it. There's a piece of the round that I deleted is a little legacy data floating around in there. It took me a second to realize what it was. It's the difference between using this round, which was what we had prior to Wildfire 5, and this round, which puts those little legs in there so your detailer can dimension to the edge. So right hold down, symmetric. And now I can create my tool. So I'm just going to make like a bump to give myself some structural integrity. Okay, so let's build a gusset. This is the form that I'm going to press into the other part, right? Sheet metal doesn't really have draft on it, but you might want to add a little bit of draft to this thing so it pulls out of the mold just right. Left click, round, right hold down, full round. New set, the other side, same thing. Yeah, I'll add a little draft to this face relative to this base. So you don't need draft on it, but it helps. And in version 13 of Pro Engineer, so this number here needs to be larger than the material thickness of the part, right? So let's think of that logic. So there's the tool, there's the clip. So I want to create a bend over the top of a form that was new in Pro Engineer version 13. So at that time, I was working at Motorola building little sheet metal beryllium copper battery contacts. And what year was that? 94. All right, so I got to reach for this form tool. There's a whole bunch of different types of forms. I'm just going to click on the form and take the default form. It's asking. I probably have a library of forms. All right, I'm just going to click on out of memory and grab one. Now, it'd be really cool because in a typical assembly mode, I'd right hold down and say, lock it to coordinate system. Okay. But people wouldn't think to be organized like this. So it's not going to be a coordinate system. So I'm kind of going old school. I'm placing it like I'm in an assembly mode. The datum, I'll connect to the datum. And look, there's my formed feature. Right. Now, when I'm doing a deep draw for like a oil pan for a car, the material is going to stretch. Creo doesn't take into account that stuff. You'd need, a specific FEA utility that could, flow mold analysis. But any changes you make to the mold, of course, Control G is going to regenerate that thing. Cool. And let's think about those radiuses that we built. Look, if I'm forming that radius is offsetting the material thickness to get the shape. This tiny radius, if it went to 0, it might not work, right? Control G. Let's put a bend over the top of the form feature. That's where in the case of a beryllium copper battery contact, that's where I'm going to kiss the battery, and I want it to make absolute contact. So a lot of times we would add a bend over the top of this thing. Here, I'll just quickly use these silly little. Like I said, this was new in Pro Engineer version 13. I can do a bend over the top of a. Well, that's cool. So let's think about how you would do a louver. So I'm just going to take this part and make it, I suppose, just make it bigger and convert that to a louver. And I don't know, 1 year design engine's product development team, we might have did 400 or 500 little covers for Motorola's cell phones. The sheet metal cover would cover the firmware so that when you turn a microwave oven on, you wouldn't get infrared or FM frequency issues, you know. So I'll end on that one. But this form feature, I'm going to redefine it and tell this one to be a distance. Now I can pattern it with a number, see? And this PTC's done such an incredible job. I sound like I'm a PTC employee. They've really done a good job with these tools. Look, you can, when you drag that distance, you can run completely off the edge and it still works. I'm impressed. All right, so now I've got a parametric number that I can pattern, you know. So pattern. So those I'll go a little bit more. Well, I'm patterning the wrong way. That's pretty cool. And you can copy and paste these to separate parts. And, you know, I don't know if you've seen that demo, but consider taking a Creo update training. Of course, you're not going to tell your boss you're going to be 30% faster after the class, but you'll give me 15 for sure. I think it's more like 30%, but right, how would we turn that into a louver? All right, so I'll just right hold down and delete the pattern. I didn't reboot, so my computer's running a little slow. How do I convert that to a louver so I can lose heat? All right, so I'm thinking if I delete some of these rounds, the feature is going to fail. So in older versions of this form feature, it required this bottom round to be selected properly. So I'm deleting stuff. You know, if you're a little bit cocky, you would see if that's going to update my part, right? Most people are scared to do this because it's going to fail. Right? So save it right before you do something to see if it's going to work, right? All right, so a louver typically are designed to keep water out, but let heat escape, right? So I was just going to play around with the rounds a little bit. Right, hold down, fetch a round. I don't know. I'm eager to play with draft. I've been teaching plastic part design classes, and the people that come out of that class are so much better at Creo than they were before. It's like a bit of an excuse for an advanced part modeling class. All right, so there's my rain side of the louver. Put around at the top here. Cool. Let's see what that's going to look like. Control G, right? Now, how do I remove this face so I can let the heat escape? All right, edit definition on the form. Got a bunch of other software packages open all at the same time. Exclude punch area, right? And by golly, you know it's going to pattern because we just did that, right? What's badass is copying that louver to another part. Oh, at Design Engine, we call that cannibalization because you're stealing somebody else's work, you know? All right. What What else would you guys like to see?
Art, I have a quick question. If you were to
Whose
take
voice
that
is that?
same, this is Cody Riddle at Miller Industries.
Hi, Cody.
If you take that same form tool and you take that idea of you laser cut that plate and then you wanted to form kind of like a dimple die. I believe the form tool will keep a sketch of the original cutout inside the model when it's after it's formed. Is there a way to reduce that or not have that sketch of the original
Do
cutout?
you want to take my email address down and take that after class? I'm not picturing in my mind exactly what you're saying.
Yeah, I'll take it down.
If we today's Halloween, you know, I got a 7-year-old, so maybe today's not a good day, but Monday next week might work.
Okay, thank you.
Yeah. If you want to take a shot at explaining what you're saying, so a dimple, right? That's ultimately what I'm kissing my battery with, right? And you're saying there's a sketch coming in there that you don't want to have in there?
Yeah, so if you have a hole that you
Oh,
stick
you're
like,
doing a sketched form.
no, so I used a part like you did there.
Okay.
Except for
Yeah.
it was originally cut out with like a laser, so there's a hole, and then you dimple die press, and it forms a raised section with a hole cut out in the middle.
Yeah. Send me a Zoom link for Monday or
Yeah.
Friday night even, and we can talk about that. That's how I learned, you know. It's like, show me a problem and let me play with it for a minute, you know. I love that.
Okay. Thank you.
Did you catch my email address?
Yes, sir. I got it.
Let's do something else. I told the story about working for a sheet metal shop that was doing small enclosures for the chip on the motherboard, and they only wanted to pay us 3.5 hours of our rate to do this thing, and we thought it was going to take more like 6 hours, including the drawing, to do each one of these. So I think it was one Saturday, three of us or whatever, we sat around trying to figure out how we're gonna do it in 3 hours, and we're just wasting Saturday, you know, like there's nothing to do in Chicago. So I'm gonna make this little part, whatever. I'm doing it as a solid. This is pretty cool what I'm getting ready to show you. So there's my little area that's covering the firmware, the silicone chip. What can I do to convert that to sheet metal? That would enclose the chip to keep the microwave oven from bothering my cell phone. Back in the 80s, when microwave ovens came out, your CB radio quit working because it wasn't shielded. All right. So first thing I want to do is convert it to sheet metal. Like I said, if you work for the Army, they've got rules against this, but I just think it's really old. People like making rules. So there's my sheet metal part. I'll do it at cold rolled steel thickness. I shelled it inside the utility so it's hollow. That's not gonna flatten. I don't need to click this button to see it flatten. I just know it's not going to work, right? This is a confidence builder, right? It's got other functions in there too. By the way, I would write this down. Send, cut, send is where we send all of our sheet metal prototype stuff to. They are badass, and they send a piece of candy in the package that comes back, which is pretty cool. I don't eat candy, but it's awesome. Nice touch. Let's see. So I did a convert to sheet metal over here, right? Don't get conversion mixed up with convert to sheet metal. I think if I were part of PTC's UI team, I would say call it something other than that starting with the first letter of convert. C doesn't work. This tool is very powerful, quite powerful. So what I can do is fetch all these edges, and look how it's ripping the edge, turning that thing into a model. You want to be mindful SolidWorks users like to rotate the screen. Don't do that. Click right over. You just want to be mindful to get the outer edge, not the inner edge. Middle click. And look, now he's going to flatten. Now, I don't need to click that to see it flatten, but some people lack the confidence, you know. Little Debbie box, right? So let's see what we can do to this to play with it some. Turn that off. I'm confused why it's not going away. Usually you click this and it goes away, but it's not disappearing for me. Oh, you hit the X. Great. Who would think? So let's do that again, but let's make it just a bit more complicated and organize how we're going to break the little Debbie box apart and dimples and all that stuff. So what I do is I build my dimple on here and then cut and paste it over to the other side. It's kind of silly how SolidWorks doesn't do any of that cool stuff. I don't know how people like SolidWorks better at mild ignorance, I suppose. All right, so what I'm going to do is put a point up here, and I'm going to reference the point to this other side. I don't know. 1. I was going to make it 1.5, but I'm kind of lazy. I'm going to put another point down here and make it the same distance. Lazy to reach for 0.5, right? All right, now let's turn, so we can see the points. What do we got to do now? Conversion, right? I'm going to rip the edges. Except I'm going to rip only 3 edges. It's just about to the spot where it won't grab the other side. That would be the inside. There's the outside. Cool. Now I'm going to, like in rounds got a new set. I'm going to put another rip up here. And look, you can drag this one back and hold the shift key. Control Z, do the other side. Snap it to the thing. Look how it built a round for me. I didn't put that round in. I'm just using edge rips. And I did a new set. Rip connect. I could rip connect this thing and basically kiss both of those points. That's a whole different way for a little Debbie box to open. And of course it flattens. Yeah, you can see pretty quickly. I did a class for the U.S. Army. It was a 2-day sheet metal class. And I was told before the class started that everybody had 20 years of sheet metal. I was really intimidated by that. So I prepared quite a bit, but they barely knew sheet metal. So no big deal. But look, it got the rounds. So let's organize the ob round. I think the ob round looks really nice. So let's edit definition on this thing. Corner relief. So in Wildfire 4, when this was Wildfire 4, this button didn't update dynamically until Wildfire 4. Look at built the ob round in whatever edge shape you want. That's pretty cool. I'm excited by these tools. So of course it flattens. Let's see. I think we're just about time. But if you wanted to, we could download this. I built this one at Newell last week or a couple weeks back. Let's just take a minute to poke through that and think. So Design Engine, we're pretty big on top-down design, and if you hired me to do a project and told me not to use top-down design, I'd probably decline. So I've got the skeleton file at Design Engine's got the zeros in it, the housing, the race, and the little sheet metal part, and then the assembly last. I'm just dragging them. This is a ITAR oriented zip utility. It lets me drag right in there. We hide the skeleton file, open it in a separate window and look at it. So I published a little bit of surface out of here. Published geometry is how when we teach this, we talk about it in terms of the teamed approach. A lot of people get in their head that top-down design is not appropriate. And it's fun to make fun of those people. But I think of this copy as a timestamp. And then I published the surface of the copy to get this surface here. That surface is what created the sheet metal component. Then I converted it to sheet metal, had to flatten it and organize the holes, pattern of holes. And then I used the word flatten. I meant to use the word unbend and then bend back. Those, I think of unbend and bend back as what's hiding in the parentheses. So let's go look at that little sheet metal part now. So he's got the, we call this ECG, or external copy geometry. I usually rename it, but this isn't a real project. You know, when we do projects for Amazon, they make us work inside a wind chill, and I would just rename stuff to be kind of a team player, right? But this isn't a real project. There's my thicken. There's my convert to sheet metal. I patterned it. Pattern solid bodies doesn't automatically merge it. PTC's forgot to put that button in there. Let's just look at that and let me make fun of PTC a little bit. The option would say merge what patterns, you know, or try to merge what patterns. That's not there. So I got to merge the whole thing. No big deal. And then unbend it, build a little hole somewhere. There's my hole to let the sound escape. I don't see it, but and then it's probably off the page. Oh no, there's the hole. This cut trimmed it back, I think, and then patterned the hole. 300. Right, and then bend back. So I was just suggesting in my mind, I didn't tell PTC, but it'd be really cool if they indented those about, you know, 5 characters. That way your team members would know if you want something added to the flat, you don't just add a new unbend, bend back. You go to insert and add it. You know, young people. So typically when I build something with top-down design, I just hide it and publish everything. So this has got publishes at the bottom. I think of this publish as a nice and neat tucked drawer that I can organize. And then the rest of the team is convenient. They don't need to get out of their chair and ask me what to do. We developed that something similar to that workflow at Fisher Price when we would build like the Power Wheels riding toy, and the manager wanted to get other people working on the product, but they couldn't get other people working because I wasn't done with the skeleton file yet. So if I'd have known I could have published the geometry out, I could have submitted it in Windchill, got smart interns working on their mechanism for opening the door and what have you. So that's published geometry allows managers to feel comfortable throwing people at it. That's why I call it the teamed approach. Nobody wants to argue with the team. They'll tell you top-down design is not appropriate for our project, but the teamed approach to top-down design is not. Anybody have any other questions? Pop quiz. Where do I work?
Not Fisher
Design.
Price.
Hi, Dan.
Design engine.
Fisher Price, that's funny.
All
Yeah,
over the world. All over
all over the world. Yeah,
But based in
Herman
Atlanta
Miller's
now.
got me going to India this year, so I'm training all your
God.
competition in India.
Cool. So yeah, we're probably, within 2 minutes of shutting this down. Does anybody have any quick questions?
Never a quick question.